Hello. Welcome to another important episode in the series on radiation physics. Today we will learn about concepts of radiation protection. Radiation is a part of our world, from hospitals to space. Understanding how to protect ourselves is crucial. By managing time, distance, and shielding, we can change the risk of radiation exposure. The core problem with radiation is its interaction with matter. High exposure means more damage, but protection can reduce this interaction. By managing time, distance, and shielding, we can minimize the risk. Distance plays a crucial role in reducing exposure. As radiation spreads out, its intensity decreases. Sometimes, the safest protection is simply stepping away. The inverse square law explains one of the most important ideas in radiation protection. As radiation travels outward from a source, it spreads over a larger and larger area. Because of this spreading, the intensity of radiation decreases very rapidly with distance. This reduction is not linear. If the distance from the source doubles, the radiation intensity becomes 4 times weaker. If the distance becomes 4 times larger, the intensity drops to nearly 1/16. That means even a small increase in distance can produce a very large reduction in radiation exposure. This is why distance is one of the simplest and most effective methods of radiation protection. Radiation exposure is not only about intensity, time also matters. Even a moderate radiation field can become dangerous if exposure continues for a long duration. As radiation interacts with the body, energy is continuously deposited into tissues. This means the absorbed dose gradually accumulates over time. The longer a person remains exposed, the greater the total energy transferred to the body. That is why radiation workers, medical professionals, and nuclear facilities carefully control exposure duration. In radiation protection, reducing unnecessary exposure time is one of the simplest and most effective safety strategies. Less time near the source means less absorbed radiation dose. Shielding is one of the most important principles of radiation protection. The basic idea is simple. Place a material between the radiation source and the body. As radiation passes through the shielding material, part of its energy is absorbed, scattered, or weakened. Because less radiation reaches the body, the overall exposure and biological risk decrease significantly. Different types of radiation require different shielding materials. Alpha radiation is easily stopped by paper or skin. It's not a penetration hazard but can be dangerous if ingested or inhaled. Beta radiation is blocked by light materials like plastic or aluminum. It's mainly an external hazard, so proper shielding is crucial. Gamma radiation requires dense shielding like lead or concrete. It's a significant external exposure hazard, so proper protection is essential. Neutron radiation is moderated and absorbed by special materials like hydrogen-rich substances. Proper shielding is crucial for protection. Radiation protection is applied in various fields, from medical to space. By controlling time, distance, and shielding, we ensure safety in environments where radiation is present. Radiation protection involves understanding time, distance, and shielding. By controlling these factors, we can safely use radiation in various applications. This series is brought to you by Physical Sciences Consultorium. Please like, share, and subscribe our YouTube channel. Thank you.